All right, so what I want to do here is I actually want to talk a little bit about logarithms. And in fact, using some rules of logarithms and an approach to using rules of logarithms um, that, maybe might be easier than going through and actually memorizing them and to do a particular problem for one of our students. So I look at this one and I've got log base 2 of x squared minus log base 2 of x plus 4 equals 9. And so essentially, I basically got, well, three, two or three really important rules of logarithms. One, right, is that if I have log, and by the way, I've got to make sure that I have a log. Let's say I have a log base b of a1, and I add log base b of a2, right, where I'm basically taking the log of these individually. That's going to equal log base b of a1 times a2. Okay? And then in reverse, it also works in reverse, which means that essentially log base b of a1 times a2 will equal log base b of a1 plus log base b of a2. Okay? So they're connected. So we actually only really need to know one and then know that we can actually do the opposite. Then we have the second one. That's going to be log base b of a1 minus log base b of a2. That's going to end up equaling log base b of a1 divided by a2. And its reverse, which is log base b of a1 divided by a2 equals log base b of a1 minus log base b of a2. Okay? So what we just want to notice is that if you can kind of understand that addition, when we utilize logarithms, addition across the logarithm, right, equates into multiplication inside of the logarithm, and that subtraction outside of the logarithm equates to division inside of the logarithm. And then we have a third one, okay? And the third one is if I have log base b of a1 to the n, that'll end up equaling n times log base b to the a1. So basically a power inside of the logarithm ends up multiplying outside of the logarithm. And that actually has to do with how exponentials work too, and that's somewhat inside of the video as well, or inside of our lessons. And so consequently, again, if I have n times log b of a1, okay, that equals log base b of a1 to the n. So we've got these basic rules, and now what we want to do is we essentially want to go through and we want to use them in good ways in order to, in fact, manipulate rules of logarithms. Okay? So let's say, for example, I've got this one here, log base 2 of x squared minus log base 2 of x plus 4, and that equals 9. Okay? So I'm going to use my rules of logarithms, and you'll notice that we've got the minus here, and so that's going to be this one right here, okay, where I've got the division. So this is going to end up giving me log base 2 of x squared over x plus 4, and that'll equal 9, okay? So that's cool. Like, I can actually go through and solve that. Now I have that, and the other thing that we have here, okay, now that we want to go out and we want to solve for 9, what I'm going to use is this isn't necessarily a rule, this is a relationship. This is the definition of a log. Okay, and that is that if I have log base b of a equals n, okay, that means that b to the n will equal a. All right. So what we have is we have the base of the logarithm becomes the base of the exponent, and what the y is, right, that n now becomes the power, and a becomes the value that it's equal to. Okay, so basically n and a switch places, but the base remains the same. B is the base in both cases. Okay. So what I do there then is that means that in this case it's going to be 2, and you notice this is now going to be 2 to the 9 is going to equal x squared over x plus 4. Okay? We'll figure out what 2 to the 9th is. So that's 512. So this is now 512 equals x squared over x plus 4. Okay? Now I'm no longer working with logarithms. What I'm working with is I am working with a rational function. One that I can actually then use some algebra with. So this is 512 times x plus 4 equals x squared. Okay. And let's take 4 times 512. So that gives me 512x plus 2048 equals x squared. Okay. And so this is then going to give me x squared minus 512x minus 2048 will equal 0. And then I can use either the quadratic or I can use factoring in order to solve for x. Okay? Well, let's see. Let's take a equals 1, b equals negative 512, c equals negative 2048. And then using the quadratic formula, we're going to get x is equal to negative 512 plus or minus the square root of negative 512 squared minus 4 times 1 times negative 2048 all over 2. Okay. Let's use my handy dandy calculator. So that'll be 512 squared plus, and then it'll be 4 times 2048. So all I did was all right, then I'll take the square root, see if it has. So that's going to give me 512. I'm just going to write this 512 plus or minus the square root of that's not what I'm looking for. This 270,336 over 2, which equals, see if it has a square root. Oh, snap. All right. Well, you know, basically that's what we've got. Now, a couple of things. One is to notice, I'm going to say, okay, so this is 512 plus or minus 519 0.938 divided by 2. All right. So we'll take first, we'll find x equals 512 minus 519.938 divided by 2. That's going to equal negative 7.938, and then we'll divide it by 2. So it's negative 3.9969, or somewhere around there. It's about that number. And then we also have x equals, we'll have the additional one, 512 plus basically this 519.938 divided by 2. Let's just take 512 plus 519.938. Then we'll divide it by 2. And that gives me 515.969. Now, I'm working with logarithms, and so one of the things that we need to know about logarithms is that I cannot have a negative number inside of the logarithm. So I need to check and make sure that when I plug in either one of these values, either negative 3.6969 or 515.969, that I don't end up with a negative log. Now 1 is going to be, so it's log x squared, right, minus log of negative 3.969, okay, plus 4, right? So what I'm going to do is I'm going to check and see if these are at least approximately 9, right? I got to do that. So by the way, this is going to end up being okay. So when I go in and I check those, 3.969 squared. Okay, take the log of that. So this is going to be 1 point, sorry, 9797, so we're 1.197 minus, and then we're going to get here, this is going to be 3.969 negative plus 4. So that's 0.031, and then we'll take that as a log. So this ends up being, that's going to be so this is actually log base 2. Log base 2. So this is going to end up giving me minus, and it'll be negative 1.509. Okay, and then I'm going to have to divide that through by log 2. Okay, so this is going to end up giving me so that's going to be a negative plus 1.197 divided by and so that's about 9. There it is. It's approximately 9. Okay, so that one works. Right? Notice what I used here. I used something called the change of base. So in order to use my calculator, I had to use change of base. So that's log of these values right here divided by log 2, which is the base. So I'm going to do the same thing. So now I'm going to take log of, in the next case, this is going to be 512 or 515.969, okay, squared minus log of 515.969 plus 4, okay, and then I'm going to divide that through by log base 2, okay. So I'm going to take 515.969, okay, take the log of that, all right, and then we're going to subtract from that 519.969 logarithm. That's going to end up equaling that, okay? And then I'm going to divide through, excuse me, that's 515.969, okay, squared. And then we'll take the log of that. And then there'll be minus 515 or 519.969. Okay, logarithm. then we'll divide that through by log 2. And that is also approximately 9. Okay, notice I had to check both of them. One of the reasons why I had to check is that just in case, take a look at this one right here. That one could have ended up being negative, right? If that one had ended up being negative, then I would not have actually been able to use that as an answer or response. So in this case, because it wasn't negative, I end up with 2 answers that will actually give me back 9, right? So let's just kind of review here a little bit. And I know this is a little bit longer, but we wanted to go through and talk a little bit about how to use these rules of logs, right? It just takes a lot of practice. So we go in, we say, okay, so I've got this log base 2 of x squared minus log base 2 of x plus 4. I notice that I have the minus there. That's going to end up being, right, a division inside the logarithm. And so that's what I do first. I bring them both inside so that I have one logarithm that I can deal with. Then I use the definition of a logarithm, okay, that inverse definition, to then change my base, okay? And once I change my base, then I now have the value, right, because it's now 2 to the 9, is going to equal just simply x squared over x plus 4. That's kind of how you get rid of the logarithm, is by changing it over to an exponential. Then it's just a matter of utilizing our rational functions like we've done in previous classes, where we go through and we utilize some quadratics. Now, the last thing that I want to do, okay, and I don't forget to check, right? Because the value could possibly, one of the values that you get here for x may give you no solution or not give you the solution you want. So I'm going to go in here, and what I ended up doing was, to use my calculator, I took the log of, in this case, negative 3.969 squared minus this log of negative 3.969 plus 4, okay? And then I divided it by log 2, called the change of base, okay? And so how change of base works, so that you can use your calculator, is to say, okay, so log base b of a, okay, is equal to log of a over log of b, right? So that's how that's going to work. And then I did the same thing for the other one, okay, and both gave me approximately 9. Now, remember, I did some rounding, so I'm not going to get exactly 9, but it gives me awfully close. So consequently, that actually then gives me the answer and tells me that my answers here now are x equals negative 3.969 and 515.969. Okay, I hope that helps. This kind of stuff, it basically is, it takes a lot of practice, but once you practice it, it goes pretty quick, all right? And you just have to be, kind of careful with the work that you do. All right, that concludes this video.